Welcome to the XRV-124 Phantom hardware overview. We'll talk about features of the imaging cone as well as the USB 3 connection to the laptop. To begin with, let's start with a diagram of the imaging cone from the Quick Start section of the BeamWorks manual, as well as a window of live video of the XRV-124 Phantom. As features from the diagram are discussed, their locations on the live video camera will be pointed out at the same time. The main purpose of the XRV-124 imaging cone is to convert the invisible proton or X-ray radiation beam into spots of visible light that can be captured by the digital camera at the opposite end of the Phantom. The protons or X-rays pass through the imaging cone, producing entry and exit spots to measure the beam position, vector, and profile. On the exterior of the imaging cone are 32 calibration holes, which are also called reference holes, arranged in groups of 8 holes on the top, bottom, and sides of the cone. From the camera's point of view, we call the top set of holes north, the bottom set south, and the other sets are east and west. The 4 reference holes closest to the small end of the cone, which is also called the puck, are labeled A, and the 4 at the wide end H. The holes therefore form a sequence A, B, C, D, E, F, G, and H, starting at the puck. The puck is used for mounting BB fiducials, which we will talk about in the next section. Calibration is performed on the XRV-124 by running a special BeamWorks script while using an illuminator to backlight the reference holes in a clockwise fashion: north, east, south, and west. This calibration process is repeated 4 times to produce an average image consisting of 32 white dots on a black background, which is saved for calibration. This image forms a precise pattern that enables the BeamWorks software to map 2D pixels from the camera onto the virtual 3D model of the imaging cone. The calibration process is described in Section 4.8 of the BeamWorks manual and should be performed at least once per year or after the XRV-124 has been subjected to strong vibration, like being moved between facilities. A complete XRV-124 end-to-end test will need to use the KV imaging subsystem during the proton or LINAC diagnostic delivery. In order to maximize the flexibility of the XRV-124 with various styles of image guidance, 11 fiducials are available on the image cone. All BBs are 2.5 mm in diameter and are made of tungsten steel alloy. To begin with, the puck has 4 embedded fiducials that form a plane through its center. This plane is the origin of the z-axis of the XRV-124 measurement coordinate system. It's the place where z equals 0 within the BeamWorks software. These 4 fiducials are offset by 22.5 degrees, so orthogonal imaging systems like the Accuray CyberKnife can view all 4 puck BBs at the same time with each X-ray source and panel. There are 8 large holes located around the edge of the puck that are used to hold more fiducials. 2 of these holes are filled with what we call button or digit fiducials because they look like a small finger with a single BB in the center at the end. 2 other holes in the puck support the base of the probe 145. The probe has a thin carbon fiber reinforced plastic rod that suspends a BB directly under reference hole F, approximately 145.3 mm away from the origin at z equals 145.3. This BB is close to the center of the imaging cone where x equals 0 and y equals 0. Diagnostic deliveries usually aim for x equals 0 and y equals 0 at some chosen distance from the origin. Finally, there are 4 more fiducials near the base, or wide end, of the imaging cone. These fiducials are also rotated 22.5 degrees from vertical like the puck BB fiducials. For advanced users with different imaging needs, Logos Systems has a product called the Talon 124 that, along with the center probe 145, has 4 arms that extend along the outside of the imaging cone. Each one of these arms have 7 BBs, each with a spacing of 20 mm. These 7 BBs line up with reference holes A through G on the imaging cone. The Talon 124 mounts directly on the XRV-124 puck using 4 thumb screws. The XRV-124 needs to be scanned in a CT to create diagnostic treatment plans that take advantage of one or more of these fiducial BBs. The Pro BB is a good place to begin. Some customers simply use the white scribe marks on the top of the sides of the imaging cone to align the XRV-124 with the room lasers. One laser for the top, one for the side, and one crossing at reference hole F. This gives fast results, but room lasers can be out of adjustment by as much as 1 millimeter. Advanced users will want to use beam diameter measurements captured during star shot metrology. Shooting directly at the Pro BB will cause a shadow in the exit spot, which affects beam measurements. Shooting off axis so that the beam is closer to reference hole G is a useful solution. Delivering multiple energies at each gantry angle yields volumes of useful data from the typical 12-angle, 30-degree star shot. BeamWorks Delta enables users to quickly extract single-energy star shot folders from a multi-energy star shot dataset. The black plastic shroud that covers the imaging cone is 0.8 millimeters thick and does not substantially affect the measured size, shape, or portion of the proton or X-ray treatment beam. The purpose of the shroud is to prevent ambient light or laser light in the treatment room from illuminating the calibration reference holes on the imaging cone. The shroud can be easily lifted off the cone by first removing the tape that holds the ends together. Using the XRV-124 without the shroud is useful if laser alignment is somehow part of the chosen measurement procedure. The treatment room lasers and lights should be turned off if the XRV-124 is being used without the shroud. The shroud will need to be removed during the calibration procedure. A hybrid approach to removing the shroud would be to remove only the tape and keep the shroud attached. The shroud can then be rotated around the imaging cone to expose only reference holes, north, east, south, or west, needed for the laser alignment. If the BB fiducials are always being used for image alignment during star shot capture, then it's recommended to keep the shroud mounted. The 30-meter USB 3 extender cable supplied with the XRV-124 is called power-over-fiber-optic because the laptop powers the digital camera through power wires in the cable. High bandwidth signals are converted to light at the laptop end of the cable and converted back to electricity at the XRV-124 end of the cable. The cable does not support USB 2 signal communication. The cable is supplied on a plastic spool for a quick setup from the control room through the maze to the treatment room. Care should be taken that the cable is not pinched or crimped when the treatment room door closes. Avoid stepping on the cable when it's laid out in the maze. A large proton treatment center with multiple treatment rooms should consider purchasing additional extender cables from Logos Systems for routing directly from the treatment room through the wall to the control room. Having dedicated treatment room cables will save 5 minutes of physicist time each time the XRV-124 is used because unspooling and respooling the cable is not necessary. This will also maximize treatment room uptime, especially if the XRV-124 is used for daily diagnostics. The XRV-124 can be plugged directly into the laptop when capturing calibration images. The extender cable is not necessary. Calibration can be performed in an office setting, but the office lights will need to be turned off. This concludes the XRV-124 Phantom hardware overview. Please continue with the next video that discusses the Logos Systems BeamWorks software and includes a proton beam star shot demo. For more information, please call us at 831-600-6101.